hope I'm audible for everybody. Okay. Thank you, guys. Thanks for everybody here. So let me start with a quick journey about how Aadhaar and how my open source work and other works happens and what I do in the security and the data privacy space, okay, both within India and outside of India. This was around 2009. I started working for Aadhaar. My expertise is potentially on math, and then I moved into cryptography. So whatever you see in Aadhaar as a cryptography is totally what we started to begin with in a large-scale cryptographic work, because until then, there was not enough large-scale cryptographic work. And the challenges that you face in working in India or any of the developing nations that you continue to work more, you realize is most often you're not well connected. So most of the cryptographic work that you see is about connected technologies, or you kind of have some kind of hardware security built in and then you're trying to use it. Your first time you're working in a space where you're not connected, you're going to have systems which are general purpose systems that are going to be used and not special purpose systems that you could use, because it's very costly to use special purpose systems. So you're faced with humongous challenge about, at a large scale of India, you're working in an offline first mode. Your systems are not connected. You don't know what your operators are entering. You don't know the quality of the data until it reaches the server, and sometimes it takes us multiple days to reach. So for example, there was a time in India as well as in Philippines where we worked. People used to carry a large set of UPS with the batteries and everything, and then their laptops go into the field for next 20 days. There is no connection, no communication, nothing. They're just in a remote island, remote villages, trying to collect data in the remote mountains, and then it takes 20 days by the time they come out and then give us the data. So it means you're clueless about what is happening in those spaces, right? It's a huge challenge, because if you can't see what is happening on the field, you can't correct anything that is happening wrong, right? So it became imperative for us when we started designing that, one, if we want to have a good quality, we need to have less data that we collect. So if you see in Aadhaar, probably it's one of the world's first identity system which collected extremely less information out, right? We collected basically a small demographic information, your name, your date of birth, and your biometrics. Only 4. We collected nothing else. If you look at identity systems across the globe, which I'm interacting with today, there is a country whom I'm interacting with, they have 147 data fields that they want to collect. Okay, 147. It's written in their law. There is another country which says, every data that I collect, somebody has to eyeball it manually. They have to look, eyeball it, okay it, only then I would be able to trust that data. So look at the laws that are being worked around in multiple of these countries that we face versus what we have done within our space. So it takes a lot of time to make them understand that making a data livable and breathable is very important. If a data doesn't live, the data quality becomes a big issue. So it needs to ensure every single data that you collect is used on the field, and people continuously change that. So for example, if you look at countries in the northern part of our world, their data is not exactly living. They have an extremely stale amount of registry, just like how our fungus happens, right? The data is like too vast, too much of information. Nobody updates it after the first 1 year or 2 years that they collected. The problem with that kind of a data is you can no more rely on it to do anything about it. But in other kind of systems, that is a livable data. That essentially means every single data is needed by somebody else. So in order to do that, you will it is in your best interest to keep the data up to date, and you end up being up to date with the information. So your address is up to date in Aadhaar most often. Your phone numbers are up to date in Aadhaar most often, because there are connected systems which are needed. So if you see, when we started moving into Aadhaar in 2009, and then somewhere around 2012, 13, we found that the digital signatures were slowing us down. So we had to really go out and create something called e-signatures, which we wrote a paper, and there were a lot of back and forth between it. Finally, the government agreed to do and experiment that. So that's the first time we ever said, the entire cryptographic key for everybody in this country will live exactly 5 minutes. I don't know how many of you know what happens behind the scene. It just lives exactly 5 minutes, signs only one document. The lifetime of the key is only to sign one document, and then the key is forgotten, because the key is based out of a natural identity, which is like Aadhaar. So your public key is based out of Aadhaar, so it just naturally lives only for few minutes and then dies out of it and lives only for that document. You know what that enabled you? That enabled you in a situation where you're having extremely minimal information, which means the e-signature platform had no information about you, not even your keys, because they're all based on the identity system. So we relied on a data that existed somewhere else rather than building a huge, large system once again, right? In the past, you used to send a USB token to everybody. I think a lot of you are not in the income tax things, but if you're in the income tax, you will realize the number of authentication that it can potentially do and the speed at which it can operate. All of that is possible because you design systems simple, look at extremely minimalistic data, and make sure that data lives. That's the most important thing. The data has to live. So if OTP has to work, everybody ensured that their phone numbers, even if they change, they keep moving their phone number, right phone numbers into the Aadhaar database. So it ended up being a livable information, more accurate enough that you can rely on in certain situations, right? Similar things with biometrics. You would see the exactly similar concept in biometrics. I think a lot of you here would not use biometrics, but when you go down the villages, that's the only form. The way in which the biometrics are working in the Western world versus what works within Aadhaar and the newer age of biometrics is a little different. In the Western world, the whole biometrics is about personal devices, or a single device, one biometric. Either you carry a card with that, or you have a fingerprint device which is specific for yourself, right? And think about having 1.4 billion people and trying to build either card or devices. The cost of such a system would be humongous. And updating it, keeping it live, and ensuring it every time it is updated, and ensuring people like my father will not lose it is impossible for a country at our scale. So when you work at scale, you need to think about what is the simple and easier other way to do it. And the most easiest way to do it is bring in an assisted form of biometrics so that a cyber cafe person who's running a small cyber cafe in a village could actually assist everybody in that village and ask them to enable for pension schemes, LPG subsidy to everybody else, right? So little thinking of what we come from or where we come from. So I grew up in villages. I know how much of assistance is important for everybody who do. My father lives in a village. There is an assistance that he needs regularly with the people. And the society actually does that. It's not that I have to go and assist him as a son. The society actually does that. The people who live there, the kids who end up living there running a smaller businesses actually run the AEPS centers. They run the other kendras and centers through which you can actually update and keep the information live. So it's important to think about how does the mass scale work like that can happen. So if you think about, so for example, somewhere around peak of the COVID time, we are trying to build the COVID system. So you would have seen, I don't know how many of you know, the COVID system that you saw where you would go and download your verifiable credentials from the COVID systems. Those are based out of an open source platform called DIVOC. It's again in the open source. The strong advocacy is if you're building something for the public, let's keep it open source. I think I'm very happy to see so much of open source work happening here because you never know who would end up using it. So we started DIVOC based on another open source project, which was actually for an education system. We wanted to run a large-scale education system called Diksha, and there was a registry. We built it. A lot of you would have seen QR codes in your in your books. Those QR codes actually connect back to those systems. They name it a little different, but they'll connect back. So we based out of those same system and then built a DIVOC, which actually ran the entire COVID platform for quite a long time, right? So keeping something simple and ensuring that the data is livable and it is usable by the people repeatedly by ourselves makes it easier and makes the data quality far, far better. But one side is about data collection and data quality, which is something that we could work around. A lot of us are trying to crack that puzzle. I think medical data is the most complex. Remaining all are a lot more easier with the way we have done it. Medical has its own challenges because it's a little different in its way we want to use that. But if you compare the other data, like you want to look at voter registry, you want to look at our family registry so that you can distribute PDS distributions or anything, the data could be very condensed, very simple, and easy to use, and could also be very well anonymized. But anonymization also has a huge problem in these kind of data structures. So when we started anonymization, this was about 3 years before we were working on anonymization. And the biggest challenge in anonymization is most of the anonymization is either pseudo-anonymous or you throw too much of data or too much of anonymization around, you end up finding out who that individual is. For example, one of the classic way we wanted to do is we want to do age-based, some amount of anonymization based on the age and aggregate some information and keep it. It looked very well when you are at an India scale. You look at child and do 0 to 10, what's the data looks like, and then do this 10-year category and then see what it looks like. Looks very interesting until you reach somewhere around 75, 80 kind of a time period. You start seeing the dip in the people. You see lesser in people, and then you would start seeing some places there is only 3 or 4 identifiers in the bigger regions. You can go and pinpoint those people and actually find their homes very, very easily if you end up doing those kind of anonymizations. So it is important that any anonymization techniques that we used, it doesn't matter however we used it, if you have too much of data and you start combining them, you find out who that individual is. And then that results in a privacy problem. But privacy is, again, very, very personal about things. So for example, in 2008, I was having an argument with a brigadier from Army. And we were in the security event, large security event. I used to run a large security startup before. So we used to have an argument there. And then he said, Sasi, why do you need privacy? This country doesn't need any of those things. See, look at our security people. We are safeguarding all the things that are happening from outside. All people inside, we are all Indians. We should all be able to access data. I said, what if the government sees too much of data? Is that OK? It's our government. Let them see it. There is no problem. No issues. So, and then he said, historically, we are not a very privacy-specific country, so why should we worry about privacy? It's a Western philosophy. I told him an example of how it is ingrained into fundamental rights of what we do and how it is followed in every single place, right? You go and observe how your mom or dad interacts with your neighbors. You'll start seeing how much of information is hidden from your neighbors. Every neighbor of mine would know my father's salary as different numbers. Right? So it takes some time to realize it's not a Western culture alone. It's our culture as well. My mom has never revealed my father's salary to anybody. If it is somebody who's a borrower from whom she borrows, the salary is higher. If it is my neighbor who's poking her nose, the salary is lower. It changes. Every time the number changes, right? What you have in your bank, what you tell would always change, right? And now if you speak about privacy as Western topic, it looks very, very stupid. It's part of our culture. That's how we grow. We did it a little differently, and we want to do it a little differently in the digital world, because in the digital sector, what happens is when one information is leaked, first time, good, no problem, you get it leaked. The second information is leaked, then the data gets associated with the first one. People tend to associate data as and when the leak happens. I can assure you that there's no way we could stop leaking. We will leak. This is the world that you live in. We will leak. So every time you design the system, we want to be a little more careful about what we put into that data. So if you see in health, right, you would have spoken about a lot of health sectors. There's a concept of ABBA ID, and there was a lot of discussion about why ABBA ID? Why should I create one more ID when we have other as large identity systems, right? The basic philosophy is this. We can't guarantee you that the data cannot be leaked. Yes, we will do our best to ensure best of the cryptography that is available. We can try to make sure we are good at it, but the guaranteeing it is very, very difficult in its nature. So it is important to make sure we do not end up in a situation where a hacker could do a 360-degree profiling on you and could actually pinpoint and target you, right? We have seen a lot of physical attacks happening on individuals. Your mobile data could be used. There are private companies which own your data. Some data here and there, not just from the government systems, from outside as well, can actually come back and associate to you, and it's not a good thing. In 2022, we are doing, about 2 years before, we are doing an analysis with the Alan Turing Institute of London. And the interesting work is, does HTTPS protect you from privacy problems? And then we said, yes and no. I think we had few professors who said no. We had some of the others who said, no, HTTPS absolutely ensures you have the privacy that you need in order to do everything that's necessary. And then we started this detailing. This was peak of COVID time. You have nothing else to do, right? Entire night and day, you're just working. There is nothing else to do. There is no entertainment enough. So a lot of discussions are happening. And then we said, OK, we'll take one exercise. We'll take out Wikipedia. And we said, let's have an automated system browsing Wikipedia, and let's capture this information, which is fully HTTPS enabled, right? We capture in between and secured data. And we wanted to see if I can find out what are all the pages of Wikipedia that you browsed. This was an easiest way to test this, okay? You can take this and then say, if you design an API exactly replayable data, which is non-idempotent API, you would see the exactly same results, okay? So we took this Wikipedia because it's non-idempotent, right? So you say, you take this Wikipedia data and then you do this analysis on an SSL traffic, okay? Mere guesswork in quite a places, but we were able to determine at 90% accuracy every page you browsed. And this is with Diffie-Hellman and PKI enabled on your Chrome browsers. Okay? That's the level of information that we leak, knowingly or unknowingly. So when we design systems, it is important to not assume the channel that you're working on is going to give you 100% security. It is important to keep adding noises in the data as much as you can and also segregate it wherever is necessary, okay? That is part of the learning that you would have, and we have introduced that in quite a lot of our APIs where the APIs do not take exactly same information all the time. It takes different information every time. There is different data that comes in. Every single time there is a randomness that is brought in into our APIs so that it is easier and better for us to do that, right? Again, I'm not telling that would protect you from everything. It's a running target. We keep researching, you keep finding out, you keep working with the colleges and professors and researchers to see what on the field is happening and then continue to improve it, okay? That is potentially how you do. You ensure your data, whether it is for security reasons or privacy reasons, your data has to live. And if the data doesn't live, we are in serious trouble, and the data becomes stale. That also is the honeypot for quite a lot of attackers, okay? Thank you, everyone. Thank you for it.